Okay, this is Unit 5c, which is the metal-based materials, and this is the sources and origins. So your objectives today are: know how metals are mined and extracted from raw material, understand the processes involved in extraction and refining to produce workable forms of metal, be aware of the sustainability and ethical issues in metal production and its use and then end of life. Grades 1, 2 and 3 will be able to identify specific types of ore used to produce well-known metals. For your 4, 5 and 6, you'll be able to describe the positives and negatives of both the open cast and underground mining operations. And then 7, 8 and 9 will be able to explain how blast furnace is arranged in order to separate the iron from the ore. So, mining. You've got a sheet to fill out on the right-hand side. So we've got bits about surface mining and underground mining. These metal ores are mined from the earth. They're mined either using surface or underground methods, and these are both going to be quite energy-intensive processes. Think about the impacts that arise from the process of mining and transporting the materials, and the benefits that it might bring to a region as well, economic, social. The image that you've got there shows the different machinery that's going to be used, so think about the scale that we're working on at this point. Now, surface mines, as you can see there, quite a big blot on the landscape, changes the overall feel and look of a landscape. You can see the road, which is snaking its way right from the very top and then working its way all the way around the outside, spiralling down into the centre of the cut. The advantages of this type of mining: it's cheaper to access the materials. Effectively, you're just digging a big hole. It's a more efficient material recovery process, so you're basically digging everything out, which means you're not leaving any behind. You've got less hazards or everyday hazards for the workers, so effectively they know not to fall down a big hole, but that's about it. They don't need to worry too much about any other hazards, as long as you've got this hole and it's safe with your working, then everything's fairly secure. In terms of the disadvantages, you're going to burn a lot more fuel to run the machinery to access the actual materials. So because you're taking so much out, then a lot of the stuff you're taking out is worthless, it's pointless. It's just going to be taken out so that you can access something quite deep. Blasting can be dangerous, so often you're going to hit rock and you need to blast certain elements away in order for you to continue the dig, and then it is going to be quite scarring on the landscape, as you can see. Underground mines. These ones have got a less visual impact on the environment. So effectively, the land above can still be used, so you can still have farming going on. The majority of places which have got underground mines have still got a working city or dwellings above it. And then you've got more flexibility. You can follow the seams. So if you're working, maybe you're extracting gold, for example, and the seam of gold starts to head left, then you just send your tunnel left. It would be a lot more difficult if you've got an open cast mine to do that. Disadvantages: you can get subsidence, so obviously you can get cave-ins, you can get collapses, you can get problems in terms of the shaft network. You get a lot of dangerous underground conditions, build up of gases. You could have it so that you get a gas pocket released, you could have a small explosion down there. You might even have it so that people get stranded, and if they do get stranded, then it's very difficult to mount rescue attempts at such large depths. And then you have quite expensive machinery and equipment, which you're going to have to then transport down into a shaft rather than just drive it down like the first option. So, different ores produce different metals. So you've got to try and match the correct ore with the correct metal by using the clues below. So, bauxite. Once it's refined, it's used to make products like step ladders and kitchen foil. Okay, aluminium. Calamine, once refined, is used to galvanise other metals in order to protect them. Zinc. Zinc is the coating that you get in the galvanisation process. Chalcopyrite, once refined, is used to make pipes and wires due to its ability to conduct heat and electricity. That one's quite clearly copper for the conductivity. And hematite, which is used for the casting and the base metal for the alloy steel. That one is quite clearly iron. Now, iron's got quite a few different ores which can be used to create it. Okay, so you've got hematite there. You've also got things like magnetite. There's quite a few different options. Once these metals have, obviously, these ores have been dug up, they need to be refined. So mined materials are not usually available in a state where you can just pick them up. Something like gold, you might just be able to access it, pick it up direct, and then work with it. but a lot of metals you need to do some kind of refinery process. Smelting is one where it chemically alters the raw material, whereas refining doesn't chemically change it, it just purifies it. Okay, now, task 3, this is to do with the blast furnace, which is the bottom of your sheet. So using the information on the following slides and the video clip, complete the correct order for the blast process, the blast furnace. So effectively, the smelting process is once the ore is mined, then you've got to separate all the waste away. The idea is you're going to get the ore, you're going to get a bit of limestone, you're going to get a bit of coke, and by coke it's kind of like not fully burnt coal, and it burns to a higher temperature. So the idea is they're going to put this coke in so that it can get to a lot higher temperature, and they put it in at the top. The ore will have been ground up, it will have been not quite powder form but not far off, and it'll enter the top of the blast furnace. Effectively, the top of the blast furnace is going to have a steady feed of the ore, the limestone and the coke coming in and entering the top. The waste gases, they're going to remove themselves via the vent port there. And in terms of temperatures, the top is around about 200. You're then going to drop down to 500, 900, 1200, 1700. They are pumping hot air, hot oxygen in here. And as long as they're pumping that hot oxygen in, then it means that it'll be able to burn at a lot higher temperature than it normally would. So you're pumping in that hot air. That hot air is effectively combusting instantly the moment it goes in, and the high temperatures are then reducing the ore, and it's going to start to allow the metal to leach out. The metal is going to liquefy at around about 1538 degrees, and it's going to sink slowly down to the bottom. Okay, when it gets down to the bottom, then it's going to go through this layer of slag, which is the waste product, and it's going to go into this bit where you've got the molten iron right at the very bottom of it. Okay, the slag waste, which we don't need, gets tapped off, that gets removed here, whereas the molten iron comes out as what we call pig iron, and it comes out right at the very bottom. Now, this pig iron runs off and it goes into rectangular moulds, and it's kind of like a conveyor belt, so you can see it coming directly from the machine there, drops into a pouring crucible, and then from there it goes into these rectangular containers here, and then they're going to be conveyed along. Okay, you can see as it's cooling, as it's going down the different phases. It's got a really high carbon content, it makes it quite brittle, and some of the carbon and the other impurities are removed, and then it gets to make things like steel. Right, so it's not too usable at this stage. Now, there's a video link that you would normally have on here, so I'll actually link it and put it onto the homework task as well, so you can see that. Dumping metal. Recycling metal is quite a beneficial thing to the planet, because we've only got so much on planet Earth, so it makes sense to then recycle and use as much of it as we possibly can. All right, so you think about metals. Metals take a long time to have any sort of decomposition, any kind of oxidization. Things like rust can affect them, but in reality the metals are around for a hell of a long time. If we put it into a landfill rather than recycle it, think about the different effects that this would have on the environment, bearing in mind that we can recycle most metals. So metal recycling can be done without altering its properties. It gets processed, shredded, melted, purified, and then it's ready for use again, so we can make it into everyday products. Think about what factors designers and manufacturers should consider when designing metal products, and how we can maybe factor in this recycled metal. Again, got another video link for you to quickly look at. Okay, task 2 is going to be to complete the exam style questions, which are on the back of the worksheet. Remember, 1 minute for every mark, so you've got 15 minutes roughly you should be spending on this. 1 mark, just make 1 point. If there's more than 1 mark, then think about how you can maybe divide it up, if you've got to make 4 individual points, or if you've got to make 2 points and justify and explain them. All right, good luck.